let's try this again. Sorry about that. We're going to pretend for Jody that she's the luckiest girl going, and she got 3 successes, 3 kings. Okay? All right, now let's take a look at the question that goes with this example. What is the probability after 3 draws? So Dan had 3 draws, 1 success. Mark had 3 draws, 1 success. Mickey had 2 successes, and then we pretended Jody had 3. What is the probability of getting a face card? Now, I'm highlighting that little letter, that little word, because I don't want you to think of it in terms of 1. When I say what is the probability of getting a face card, that's all of the possible outcomes. All of the possible outcomes. Not just one single face card. Okay? Be really clear about that. Okay, do me a favor. Let's divide this question in half. And we're going to look at this question 2 ways. Traditional probability way, Bernoulli trial way. And you're going to discover something kind of cool. Now, the traditional probability way is that I'm hoping that you recognize that this was a selection question. I fanned the cards out in front of my 3 or 4 people, and they selected a card and put it back in. So the possible outcomes, we could have had the situation where there were 0 face cards. We did see the situation of 1 face card, both Dan L and Mark I. We did see the situation of 2 face cards. And we pretended to see the situation of 3 face cards. Okay, so let's set up the selection. You know what a selection looks like. And for this particular selection, because all the cards are going back in the deck, we're going to have a beautiful 52 on the bottom for every one of my volunteers, okay? Now, 0 face cards. That would have been the situation of getting a numbered card on every draw. Now, we didn't see that, but that would have been 40 over 52, 40 over 52, and 40 over 52. So, top by top by top, divided by bottom by bottom by bottom, gives us a rough probability of about 46%, 0.4552. The situation of 1 face card, let's pretend that we are like Mr. Laval and Mr. I. Face card on the first draw, numbered card, numbered card. Now, I'm hoping that you recall with the selection question, you can actually, there's an order to it. On this one, Mr. I and Mr. Laval both got a face card on the first draw, but it could have went number, face, number, or it could have went number, number, face. So we have to put that order in of 3 times 3. So top by top by top by top, by bottom by bottom by bottom by bottom, gives us roughly a probability of 41%. 2 face cards was Miss Staples. She went face, number, face. But again, with Miss Staples' draw, you have to also consider order, because it could have went face, face, number, or it could have went number, face, face. So when I calculate the probability for what occurred for Miss Staples, we're roughly at 12%. Now, the pretend situation of the Jody Martell situation of face card, face card, face card, let me just tell you, the math on that is about 1%. Okay? Now, neat. Very, very neat. And if I add these 4 options, because these are all of the outcomes, these 4 probabilities better add up to a beautiful 1 or 100%. Okay? Now, the problem with this technique, and I'm hoping you're recognizing, is that for us, we've only done selection questions where there are 3 draws, 3 cards, 3 balls, 3 candies, something like that. A selection is almost impossible once we take it past 3. It's doable, but the number of options and the whole ordering idea is very, very complicated. So we left selection questions at 3. But that doesn't mean if we do something over than 3 that, oh well, we just can't do the question. No, I'm going to show you a really cool technique, and it's called Bernoulli. Here's how it goes. I want you to think of my 4 participants, and I want you to think about that each of my participants had 3 pulls, 3 trials. And the first scenario had 0 successes. The second scenario was the Mr. I and Mr. Laval scenario. The third scenario is the Miss Staples 2 successes. And the third scenario is the Jody Martell pretend. So a combination of 3 choose 0, 3 choose 1 for Mr. Laval and Mr. I, 3 choose 2 for Miss Staples, and 3 choose 3 for Jody Martell. Now, do me a favor, multiply that for each of them by the probability of success. And the probability of success is getting a face card, and that's 12 over 52. Let's raise that probability to the number of successes. So 0 successes in the first one, 1 success for Mr. I and Mr. Laval, 2 successes for Miss Staples, 3 successes for Miss Martell. Okay, kind of looking complicated, but let's keep going. Let's now multiply that by the probability of failure for each of my participants. And with that probability, I want you to raise it to the number of failures. So hold on, 3 trials and 0 successes means that I had 3 numbered cards, 3 failures. 3 trials with 1 success means that I had 2 failures. 3 trials with 2 successes means that I had 1 failure. And 3 trials with 3 successes means that I had no failures. So combination, number of trials to number of successes, probability of success to the number of successes, probability of failure to the number of failures. And I'm going to ask that you get your calculator out and that you actually try these on your calculator, because every calculator has a different keying strategy and it's really important. So on my calculator, I'm going to do a combination of 3 choose 0. Now, with my calculator, I don't need to use the multiplication button. It works without it. Some calculators actually need that. So notice combination 3 choose 0, 12 divided by 52 to the exponent 0, 40 divided by 52 to the exponent 3. Get ready. Bingo bongo. There it is. 0.4552. Let's try another one. Combination of 3 choose 1. 12 divided by 52 to the exponent 1. Again, you're going to have to mess around with your calculator. 40 divided by 52 to the exponent 2 for 2 failures. There we go. 0.4096. Let's do the next one. Combination of 3 choose 2. 12 over 52 to the exponent 2. This is the Miss Staples scenario. 40 over 52 to the exponent 1. There we go. And let's just go on a little leap of faith that the probability for my scenario, the 3 successes, is identical. So what you've just seen is you've seen sort of the old probability selection technique and the new Bernoulli trial technique that allows us to use this particular formula because the trials are independent, the trials are repeated, and there's only 2 outcomes. Fantastic. Now, if we look down here, you will see that we have the formula with all the little call letters. I don't have it memorized that way, and I really wouldn't suggest. I have it memorized in words. So the words are combination, number of trials, to the number of successes. Times the probability of success to the number of successes, times the probability of failure to the number of failures. Again, to me, when you have the formula memorized in words, it's much easier, guys. It's much easier. So trust me, when we're doing our examples, you're going to hear me repeating a lot of this so that it gets ingrained in your brain. Okay? So when do I use Bernoulli? When you have independent, repeated trials with 2 possible outcomes. It's a shoo-in. Okay? That's when you use Bernoulli. Okay, let's flip when we're ready. What is the probability of drawing exactly 6 face cards, key word, if you played the game 20 times? So what is the probability that I would get exactly 6 if I had 20 trials? Okay, so again, this is the 2 outcomes, right? Face card, not face card. So number of trials, 20. Number of successes, 6. Probability of success, 12 over 52. To the number of successes. Probability of failure to the number of failures. Now be real careful here. This is where the sillies occur. The number of failures. Now let me think about this. If I'm playing 20 times, or if I have 20 draws, and 6 of them are successful, that means that 14 weren't. Calculator, roughly 15%. What is the probability of drawing 5 or 6 face cards? Now, we're familiar with the word exactly, and we're also familiar with the word or. That's been for 3 units now. If we play the game 5 or 18 times rather. So 5 face or 6 face. I'm hoping that everybody out there remembers that 5 face or 6 face means add those options. 5 or 6. Number of trials, number of successes, probability of success to the number of successes, probability of failure, careful, to the number of failures. Well, if I have 18 trials and 5 successes, that means I failed 13 times. Number of trials, number of successes, probability of success to the number of successes, probability of failure to the number of failures. Careful. Number of failures, 18, 6 successes, 12 failures. Now, the bulk of your marks is going to be from this work right here. I'm going to assume that you're going to get the calculator stuff right. And that's why I'm not spending a whole heck of a lot of time on the calculator work. Okay, the chunk of your marks, the bulk of your marks are going to be right up here. And then if there's a silly someplace in here, you're losing a half mark. Okay? What is the probability? What is the probability of drawing, you knew it was coming, at least 2 face cards? Now, at least 2 face cards